Alright, hey guys, so today we're going to talk about 6.5, so the double angle formula. So what if I have, instead of sine of theta, I have sine of 2 theta or cosine of 2 theta? Alright, so what we're going to start with is if I give you sine of theta equals 3/5 and I give you where it is, find the exact value of sine of theta and cosine of 2 theta. Now let's go back for a second and notice that there's only one possibility for sine of 2 theta, but there's three possibilities of how to write cosine of 2 theta. Now, you can write it any one of these three ways. Sometimes though, and I'll show you this later on, it's going to be easier for you to write it one way versus the other. You'll get the same answer either way, but if you write it one way versus the other, it's going to be kind of an easier process to get there. So just keep that in mind, and I'll show you kind of how I think through which one of these three identities will be the easiest way to do it. Okay? Alright, so let's go to the first example first. Alright, so if I have sine of theta equals 3/5 and it's between pi over 2 and pi. So here's pi over 2 and here's pi. And, well, that doesn't really look like a triangle, but that's okay. So it says that it equals 3/5. So I know sine is opposite over hypotenuse. Okay? So I know that this is going to be a 3, 4, 5 triangle. If you didn't remember that, you could use Pythagorean theorem to find the length of the opposite side. Here's the key though, is that this has to be a -4 because I'm going to the left 4 units. Okay, so make sure that you mark that as a -4. This is a +3 because I'm going up 3 and the hypotenuse is 5. Alright, so now I want to find sine of 2 theta. Now it's not just going to be 3/5 times 2. Okay, we have to use our identity, which is sine of 2 theta equals 2 sine theta cosine theta. Alright, so 2 sine theta cosine theta. Alright, so I'm already given that 2 sine of theta is 3/5, and then cosine of theta, well, that's adjacent over hypotenuse, so that's going to be -4/5. So I'm going to have to do a little bit of multiplication here. So that's going to be 2 times -12 over 25, because I'm just going to multiply straight across. And then I get -24 over 25. Alright, so that is going to be the answer for A. Alright, next we have B. So cosine of 2 theta, this one, it's not really going to matter which one you choose. It's not going to make it any easier or any more difficult depending on which one you choose. I'm just going to go with the first one. So cosine squared of theta minus sine squared of theta. Alright, so we said cosine of theta was -4/5 adjacent over hypotenuse, but I'm going to square it, minus sine of theta squared. Alright, so -4/5 squared gives me 16 over 25, and notice that's going to be positive because a negative times a negative is a positive, minus 9 over 25 equals 7 over 25 when I subtract them. And no matter which of your three identities for cosine of 2 theta you used, you should get the same answer. Okay? Alright, next page. So establishing this identity, tangent of 2 theta, we're actually going to go back to the last unit that we did, which tangent of 2 theta, we're going to use the sum identity. So tangent of theta plus theta. Okay, because tangent of 2 theta is just theta plus theta. So in order to do that, we have on the top tangent of theta plus tangent of theta all over 1 minus tangent of theta, tangent of theta. Whoa. And again, that is your sum identity for tangent. So it's A and B, and then 1 minus tangent of A, tangent of B. Okay, so we can simplify this up top. Tangent of theta plus tangent of theta is just 2 tangent of theta, and then tangent of theta times tangent of theta is 1 minus tangent squared of theta. So that checks out. Okay, so that's just using what we did in the previous notes to prove this identity. All right, now this time I have sine of 3 theta. This one's going to be a little bit more complicated, but we can do it. All right, so sine of 3 theta, I can break that up into sine of 2 theta plus theta. Okay, so we're going to have to break this down a couple different times. Okay, so we're adding. So since we're adding, we can go back to what we did previously, and this is going to be a sum of sine of theta. So it's going to look like sine of 2 theta cosine of theta plus cosine of 2 theta sine of theta. Okay? And that's just your sine of A, cosine of B, cosine of A, sine of B. That's just your sine sum identity. Okay? All right, so then I can break this guy up further. Sine of 2 theta is just 2 sine of theta cosine of theta. All right, so I'm going to go ahead and simplify. Right here, I have cosine of theta times cosine of theta. That gives me cosine squared of theta. And then right here, I have cosine of 2 theta. Now, this is where I said you have a couple of choices here. Now, I see I want to get to sine cubed. Okay, so I'm going to choose the one that has sine squared, because I know sine squared times sine will give me sine cubed. Now, again, you could get there the other way, but that's probably going to be the easiest one. So I'm going to choose the identity that's 1 minus 2 sine squared of theta. Okay. All right, so right now I'm at 1 minus, or 2 sine of theta cosine squared of theta plus sine of theta, because 1 times sine of theta gives me sine of theta, minus 2 sine cubed of theta. Okay, so I'm getting somewhere because I have a sine cubed of theta. All right, so next, what I'm going to do is I'm going to use my Pythagorean identity. Now this one's pretty tricky to kind of recognize, but cosine squared of theta, I've got to get rid of that guy because I don't see cosine anywhere. But I do know I can rewrite cosine as 1 minus sine squared of theta, because I know cosine squared of theta plus sine squared of theta equals 1. And the reason I'm doing that is because I don't see cosine squared in my final answer anywhere. So I have to rewrite that in terms of sine squared. So I'm going to rewrite that from my Pythagorean identity. All right, so now I'm going to simplify this. So 2 sine of theta times 1 is just 2 sine of theta minus 2 sine cubed of theta plus sine of theta minus 2 sine cubed of theta. All right, so last step, we're just going to simplify. I have 2 sine of theta plus sine of theta. That gives me 3 sine of theta. And then I have negative 2 sine cubed, and negative 2 sine cubed is negative 4 sine cubed of theta. And that equals the same thing on the right-hand side. That one was a lot, okay? So just make sure, I probably won't give you one that tricky, but just make sure that you're able to follow the steps. Look at your end goal. So if I'm looking for a sine cubed, how can I get there? I need a sine squared times a sine. I got to get rid of a cosine. I don't see a cosine in my final answer, and looking for ways to rewrite that. Okay? All right, so next one. Sine squared equals 1 minus cosine of 2 theta. So I'm going to manipulate the right side because I can't really do anything with that left side. So this is where, again, I have some choices of what to do with this cosine of 2 theta. Again, because I have a sine squared, I'm going to write it as the identity with sine squared. So 1 minus 1 minus 2 sine squared of theta all over 2. All right, so my 1's are going to cancel out, and I'm left with, so a negative times a negative is a positive, so I'm left with 2 sine squared of theta over 2, and that gives me sine squared of theta, which equals my left side, which is sine squared of theta. Okay, so again, looking at your end goal, when you have choices with cosine of 2 theta, look at your end goal and see if you can match it up. All right, we have one more left for 6.5. Half angle is actually in 6.6. It's not labeled. All right, so this one, cosine of 2 theta, again, you have some choices, okay? Now in this one, I have cosine squared of theta in my final. So I'm going to choose the cosine of 2 theta identity that has cosine squared in my final answer. So 1 plus 2 cosine squared of theta minus 1 over 2. The 1's will cancel out, and I'm left with 2 cosine squared of theta divided by 2. The 2's will cancel out, and I'm left with cosine squared of theta, which equals the same as the left side. So I'm good there. Something like that, totally fair game. Okay? All right, and that's it for 6.5, which is double angle identities. Again, half angle is not labeled, but that starts 6.6. Okay, so I'll see you next time for 6.6 half angle formulas.